This section is on graphing sinusoids. So rather than our familiar animating our angle and going around the unit circle and looking at sine and cosine from that point of view, what we'll be doing instead is now taking this unit circle representation and going to a graph of y as a function of sine x and also y as equals cosine x. So basically, we can start off by just this simple idea of plotting points at different reference angles. So we've got 0 through pi, all the reference angles. We get sine values and approximate decimal values for those, and I plot all these points, and I get something that looks kind of like this for the first half of a period, because sine repeats every 2 pi, just as the unit circle repeats every 2 pi. Now, we can speed this process up by realizing that sine is the y value on the unit circle. It's the y coordinate, so if I animate the angle, the distance of this blue line is the same as this blue line over here. And what we see is we get this familiar sine wave graphing out. So here it is. I had graphed the first half period, and so here it is when you get to pi, and then we come around, and now sine is negative in the third and fourth quadrants because y is negative in the third and fourth quadrants, and again sine is the y value on the unit circle. And we come back around, so this is what our basic sine wave looks like. Cosine, on the other hand, is the x value. So let's hide sine and let's do cosine now. So cosine is this distance here. So this distance in green is represented as a vertical distance over here. And right there at pi over 2, we haven't gone left or right at all, so cosine is 0. Now cosine will be negative in the second and third quadrant. So again, this distance is represented by the vertical distance here of the point. And as we come back around here, when we get to 3 pi over 2, again, cosine is 0. And we'll get to 2 pi, and we get back to where we started from. And so what we see is that cosine and sine have this same general shape. Cosine starts up here at 0, 1 and starts going down. Sine starts at 0, 0 and starts at going up. So here's the two curves together. Cosine starts up 0, 1 goes down. Sine starts at 0, 0 goes up. And that's how those work. So what we want to do then is go ahead and transform these. And so we can look at that, the transformation over here. So what I've got is a basic sine graph, and I'm going to graph also a times sine of b of x minus h plus k, and we'll explore what all of these different values do. So right now, a and b are both 1, so nothing's changed. H and k are virtually 0, so the curves are on top of each other. Now if I just change a, we make a bigger, you see we have a vertical stretch that takes place. So the bigger a is, the more it stretches vertically. No displacement, that is, the graph isn't picked up or moved any direction. If a is smaller, it flattens out. If a is negative, it's a reflection across the x-axis. So here's what a does. Now let's go back down to 1 and explore what b does. For b, when we change b, a bigger b doesn't stretch, it actually shrinks horizontally. So nothing changes vertically, nothing is displaced, the whole graph is not picked up and moved. However, it is shrunk horizontally. Now if b is less than 1, you get the opposite effect, where now it is lengthened horizontally. And now if b is 0, it flips across the y-axis. So b is a horizontal stretch and shrink. Let's get this back to 1 and then see what h and k do. H is simply positive number moves it to the right, negative number moves it to the left. But note that it's x minus h, whereas there's a plus k. And so they have this opposite effect in the same way that a and b have opposite effects, minus h plus k. So now as k gets bigger, graph moves up. Doesn't stretch or shrink. Same with h. K gets negative, graph moves down. And so we can summarize these findings over here. We have f of x is equal to a times f of b times x minus h plus k. A is a vertical stretch or shrink. The absolute value of a is known as the amplitude of a sine or cosine wave. B is the horizontal shrink stretch. I reverse the stretch, shrink, shrink, stretch because it has the opposite effect. And 2 pi divided by b is the period. And so you take the natural period, which in the case of sine and cosine is 2 pi, and you divide it by b to get the new period of the function. H is movement of left-right, and that's known as the phase shift for sinusoids. And finally, K moves things up and down. That's known as the average value for sine and cosine functions, because that's basically the middle value of either one of those functions. So now what we can do is we've seen the transformations, we've seen a summary of it. The way we're going to go about doing this, though, is, and this is different than what you might see in some textbooks, some styles of doing it, but the way I prefer to do it is to graph it and then change things around it. And just to give you a quick example, this is a cubic here, and I can make the cubic look much different if I stretch things out this way, or I just change the scale of things. So it's the same graph, exact same graph, but naturally it looks so much different when you change the scale around. Or if we pick this up and move it, now we only see a certain part of it. And so just making the point that you can take the same function but make it look quite differently by changing certain aspects of it. So here are a few examples of what I mean by that. So first of all, if we're going to graph 3 sine pi x, well, what I'll do is I'll start by graphing a basic sine wave. I'm just going to graph one period 0 to 2 pi, well, one positive period, I guess. So we'll start at 0, 0, go up, come down, go up again. So that takes care of this sine. Now normally this would be at a height of 1, this would be a negative 1. Because I want to have an amplitude of 3, I will make this 3, and I will make this negative 3. So now I've taken care of that piece. Now there's a pi there, that is a b value, so to get the period I do 2 pi, the natural period of sine, divided by that b value, and I get 2. So that's my new period, so therefore this is out at 2, which is going to make this at 1. This will be 1/2, and this then will be over at 3/2, and now I've taken care of the pi. So there is my graph. So what I do is I place the graph first, and then I change things around it. This is a relatively simple example when you just change amplitude and period. When we do things with phase shift and average value, it gets a little more complicated, but the idea is similar. So now we have a negative cosine is the way I'm going to start. So negative cosine, cosine normally would start at 0, 1. I'll start at 0, negative 1. So I'll start down here, I'll go up, I'll come back down. So basically what I've tried to do is take care of the negative and the cosine. Now this is a half. So instead of this being a negative 1 and positive 1, I will put it at positive 1/2, negative 1/2. Takes care of that. Now what I'll do is change the period. So 2 pi, the natural period, divided by that b value of 1/2 gives me 4 pi. So therefore this is at 4 pi. This then would be 3 pi, 2 pi, and pi. And now I've got to move the whole graph up 1/2. Or alternatively, I can take the x-axis and move it down by 1/2. So that's what I will choose to do. So I will draw a new x-axis at the height negative 1/2. So it comes right through here. So there's my new x-axis. I'm off a little bit over here, but get the idea. Comes through right here. So when I do the new x-axis, now this is no longer at negative 1/2. This now is at a height of 0. This would be at a height of 1/2. And now this becomes a height of 1 up here. And I can go back and make this maybe more dashed line so you see that it's not really the true x-axis anymore. It's just what I began with. And so I can also move these values down here. So this is now pi, this is 2 pi, 3 pi, and then 4 pi is right here. That takes care of the plus half. And so now I've graphed the sinusoid and moved it again, everything around it. Okay, one more. This is a negative sine. And so sine starts at the origin, and now we're going to go down since it's a negative sine. So we'll come down, back up, and then back to here. So I did my negative sine. This 3 is going to make a 3 up here and a negative 3 down here. And now I have to shift the graph to the right pi over 4, but instead of shifting the graph to the right, what I will do is I will make a new y-axis to the left pi over 4. And so to try to get the scales right, you have to realize that this would be pi over 2 without shifting anything. So that's about 1.5 squares in what I've done. And so what I should do then is make a new y-axis right about here. And so what happens then is that this becomes pi over 4. This spot, this new spot, is going to become 3 pi over 4. Basically, I'm adding pi over 4 to all my normal places. Over here, which would have been pi, will be 5 pi over 4. This will be 7 pi over 4. And this would be 8 pi over 4 plus pi over 4 is 9 pi over 4. And then I can go back and again get rid of parts of this to show that it's not my real y-axis anymore. And these spots, this is still a 3 up here. This is your -3, so close enough. So that would be one piece of this. Let's fill that back in.